So, welcome back to this growth from the electrification business ecosystem kickoff. My name is Johanna Valio still and from Yrityssalo, and I will be moderating this last session, session 3, where we are having company presentations. This session is about from AI to reuse and recycling. And we will start this session with Mr. Tero Nordström, software lead and chairman of the board in SADE Innovations, who will give us a presentation on building smart battery solutions. So please, Tero, the floor is yours. I think you have your microphone muted still, Tero.
Sorry,
Please
yeah.
turn it
Can
on.
you hear me
Okay, now we hear you. Thank you, and see your presentation too.
Okay. All right, thank you. So Tero Nordström speaking, CTO software lead and also chairman of the board of SADE Innovations. Very briefly about the company. So SADE Innovations is a R&D subcontracting house providing. We have 25 experienced and widely skilled engineers doing various different things, both in the hardware and software side, including also cloud and data analytics. And we have been operational now for 3 years, a little bit more than 3 years, and headquartered in Salo, in the Salo IoT campus. And why I'm speaking here today is that we have been actually working with several projects related to smart batteries and smart electric vehicles. And then let's say that since last 2 years we have been working a lot with these kind of problems. So the common customer problem for us is that customer has a certain device or an idea about the device where the cloud connectivity plays a critical role. So they want to make these devices somehow smart. They want to be remotely monitored, remotely controlled, intelligent devices where they can kind of follow what's happening on the field. And there's a lot of commonality in these requirements. And already after like a couple of projects, we started thinking that it doesn't really make sense from anybody's point of view to always do things from scratch. What comes to these kind of IoT solutions, how to make devices intelligent and how to connect them to the cloud. So we had this common problem. Many customers said that we have something which we want to connect to the cloud, and of course there is the real reason for connecting the device to cloud is getting data to cloud and really doing something meaningful with the data, whether it's about doing clever analytics with the data and getting value from the data itself, or is it about reacting to different errors in the field and so forth. That depends a lot, but this basic problem is common for all of our customers. And because of this, we have been now working for more than 2 years on a solution for this common problem, and it's called SADE Booster IoT Asset. So it's a general purpose asset for building these kind of solutions where a certain devices want to be connected to the cloud and the customer wants to make them intelligent. And we have the basic building blocks for building any connected devices using this asset. And by having this ready-made asset, customer can first of all save time, save money. You can immediately focus on the value creation, whatever is the real value that this solution should provide. And it is tested and tried out. So it is not, you don't need to start from scratch with this solution. And also what we are really proud of is that we have been able to build a scalable world-class cloud solution. So we have already several customers where they have devices around the world, large amounts of devices using the same basis. So this is still the background, and here I have a slide about the booster building blocks, and I'm not going to spend too much time on here, but very shortly we have the building blocks for the device side, so how to connect this existing device or how to create a new device and electronics related to that one, how to connect that to the cloud, how to have a secure connection. Security is very critical on these kind of systems. Having the cloud as the second building block is of course important, storing data there and being able to manage devices and users and so forth. But then also we can provide the user interface for managing the devices and managing the data. So both the web UIs and mobile applications. But like I said, this is still background. So I think the next slide is now we come to the real topic. So Booster, like I said, it's the basis for implementing various cloud-connected concepts. And here in this slide, I wanted to give you examples of 6 different types of use cases that we have implemented with Booster that are all relevant for the audience here. So these are battery-related use cases. How do we make batteries more smart? What kind of things have we done? So of course, the basic thing, being able to remotely follow the status of the battery, whether it's the battery capacity, battery charging, battery temperature, whatever in real time, and being able, of course, analyze different issues that might be happening on the field. So take a look on the history, what has been going on with these devices. That's one of, how should I say, usually a very basic use case, what everybody wants. But of course, it's not enough to be able to just, how should I say, follow things actively. You want to get alarms. You want to be notified when something happens in the field, and you want to take actions on those. So this is another example from Booster-based projects that we have systems where when something happens in the battery that requires attention, automatically the person responsible of the system is notified. Of course, then being able to remotely control and configure these systems and devices, that's critical. So, for example, configuring charging parameters remotely, being able to configure temperature. Of course, here it is always critical that when we start talking about controlling, we need to make sure that the aspects related to safety, so that, for example, from the cloud, you can't do things which would lead to some kind of problematic situation. So always the local device is in charge, but still being able to change these parameters is one fundamental feature. In another example of a use case, what we have done is that by collecting a lot of data from larger batteries composed of large numbers of battery cells, you can get data which gives you, it provides you early signals about the of possible failures happening with the devices. And I think Accurate Mika Kandinen will continue on this topic. So I think that's a very good example of being able to kind of beforehand notice problems from the field and then being able to react to those, whether it's during the R&D phase or during the actual usage phase. Then having data in the cloud, of course, that's the kind of starting point, but what is critical is that you do something meaningful with the data, for example, visualize the data using different dashboards and business intelligence tools. And for example, we have been working with this virtual power plant concept where large number of batteries forms a virtual power plant. Being able to, for example, visualize the power trends of those virtual power plants is, of course, an important feature. And then what comes to real-time control, I will talk a little bit more about this in a while, but being able to balance the power grid by using fast frequency reserves, so batteries that can be batteries enabling to take systems out of the actual power grid, and in this way balance the grid is also a very interesting use case that we have been working on. And as a concrete, like end-to-end solution and example, we have been working with L7 Drive as our customer company, part of a project called Luxturim. This is a Nokia-led Business Finland finance project where what has been developed is a 5G smart pole, which requires also a battery backup system. And this is what L7 Drive has been working on, developing a lithium ferropolymer-based battery solution for this kind of a small scale backup system. And what SADE has been doing here is that we have connected this battery system using the CAN bus to the cloud. So there's another controller box inside this 5G smart pole that uses internet connection and cloud. And in this way, we have made the batteries smart. And for example, this virtual power plant and using these 5G smart poles as fast frequency response units is one use case that we have been implementing. And in the bottom right, you can see a picture of the web UI that has been developed for managing large numbers of these kind of poles. So I think this was a very brief overview and presentation what Sade Innovations is capable of doing and what kind of projects we have been working on. Like I said, we are a 25 people R&D company based in Salo, focusing on this kind of IoT solutions. And if you have needs related to battery and making your battery smart or whatever device smart, feel free to contact. You can find my and our company's contact information from this slide. But thank you, that's my part.
Thank you, Tero, for keeping so finely in a tight schedule and for a sharp and short presentation. We will now continue on to Accurate, as Tero already hinted, and here Mr. Mika Kanninen, CEO of Accurate, will introduce us the benefits of battery digitalization. Go ahead, Mika, the stage is yours.
Thank you very much, and thank you very much for inviting me to speak. Happy to be here today and speak a little bit about battery digitalization. Just a second, I'm sharing my screen. Just let me know if you can see.
Yes, we can see it now.
All right, perfect. Yeah, like mentioned, my name is Mika, and I'm leading a company called Accurate. We are almost 15 people at the moment, and our background is at Nokia battery research for the founders. Since then, obviously, other people also joined the company and bringing a lot of software knowledge to the company. I will talk today about benefits of battery digitalization or the usage of the digitalization and smart batteries. Then what is digitalization for the batteries all about? There is Finnish saying "jonnet ei muista," but I'm old fart enough to remember these times in 80s when the very big thing and a cool thing is digital calculators. And industry at the moment in terms of batteries are a bit on the same spot, but moving very fast and growing very fast. And battery digitalization as such, how I interpret it, is that batteries are connected. Simply, they are connected in the internet way or another. And Tero just explained a good way of doing that. Then building a digital configuration of the battery, which means a exact copy of a battery, but in form of a digital setup. So there are all the electrical connections set up in the digital system. But then it's also battery modeling. There are various ways of mathematical models of the batteries, physical models, and equivalent circuit models, and so forth. Then moving forward, why do digitalize? Today we have heard quite many topics already. What are the benefits on digitalization batteries and connecting them to the internet? And I have selected couple of benefits. There are a lot of there are more than 20 benefits in my opinion, but just to select one or a couple of them are first of all anomaly detection and early issue response. So once you can see the trends, what is going on in the battery, you can see the history, you can compare it to history, the existing performance, you can see trends there. And the earlier you know the issues, potential issues, or even possibility for potential issue, the earlier you can react and do something about it, and avoid perhaps some loss of money or loss of operation. And based on that data, you can optimize the performance the way you like. Once you know what is wrong, then you can react. You can also see once there are several batteries, like a fleet of batteries, you can see the trends in the market, how they are behaving in different locations, what's the degradation speed in some use cases, and you can compare. You can see full picture of the statistics, how the batteries are doing. And then based on the data, you can also define the residual value. In some applications, it's really important. For instance, electric vehicles. Extremely expensive components. The most expensive component in the EV is the battery. So it is also impacting on the price of a car, especially when it's used. And then you can use all this information that you collect from the field to your R&D. Did I make the battery correct for this specific application, and how it impacted on my business? So basically, you can use that information on planning your business and R&D. But then also it enables new businesses like extended warranties, battery as a service, and you name it. There are a lot of examples on that. Then how accurate is approaching that? Well, we are providing a SaaS platform for battery diagnostics and prognostics, and the name of the service or the product or the software is Diagnose. And on the bottom part of the triangle, there is extensive battery expertise that our company represents. So we have really long experience and knowledge about batteries. We understand them well. We understand the degradations. And on top of that, we build deep analytics. And we are also using some AI and machine learning algorithms to help, especially on the big data. Then the cloud solution that we are using, and we are also happy to collaborate with different partners, is that our processing of the data is really fast, and it's basically something that is enabling also cost saving and cost efficiency in the processing of huge amounts of data. And then we can build alerts, notifications, guidances, and basically what we are aiming is the battery insight, so that the customer exactly knows how their batteries are doing, how they are performing, how they are degrading, and what's the expected life of the battery. So, and our idea has been, when we have built this, that we package our knowledge and expertise of batteries to the customer use. So they can basically gain the same knowledges throughout our system. And then a couple of real life cases that we have been performing. We have had stationary energy storage. This is megawatt size, so really huge ones connected to mains network. We have been building a lifetime prediction. After certain period of use, we can give certain confidence interval about the lifetime expectation of the battery if the usage is remaining the same. Then on the mobile applications, in our project, we have seen a really big imbalance. Even though there is a battery management system, there might be some issues sometimes that they might not work exactly as they should, or there is something other wrong. For instance, some cell failures in the modules. So we have detected significant imbalance, and that can be noticed in advance. Basically, once it's kind of developing. Then also in stationary applications, really big applications, we have been giving performance alerts. There has been, for instance, too low state of charge level, and that has been impacting on the warranty rules, or warranty of the battery. So if the battery is remaining in certain state of charge too long time, we can give a pre-warning. Hey, basically you should either discharge or charge the battery in order to remain your warranty. And then also in some application, in stationary application, really big one, we have detected over voltages, and we have seen the trend that there in certain rack there has been a overvoltage gradually developing, and we have been able to give the warning about that, and the customer has been able to react that in advance. Very shortly, that was our kind of a case that we are, and my thoughts about digitalization and how Accurate can actually be partner for various players in the market, in the battery market, to take all the benefits of the data that is available there in the batteries. So get really use for the data and take the advantage of that. Thank you very much.
Thank you, Mika, for a good presentation, and also to you for staying in a schedule. Now we are reaching the end of life of the batteries, but as we learned this morning, that is not a problem, but that's a chance and business opportunity. And Mr. Kenneth Ekman, CEO of Chrysaltech, a Fortum company, is about to tell us on how to produce battery chemicals sustainably from secondary resources. Please go ahead, Kenneth.
Thank you, Johanna. You can all hear me well?
Yes, we can hear you.
Great. Yes. Thank you, Johanna, for asking me to join this webinar. Hi to everybody. 70 people are joining, so I'm excited to be here. Yes, I'm Kenneth Ekman. I'm the CEO, founder of Chrysaltech, but since Fortum bought this company in beginning of 2020, last year, I'm now heading what is called the concept and technology development for the Fortum business line battery. My team's responsibility is the hydrometallurgy of processing these secondary resources. So today was the thought to a little bit discuss the sustainability of battery chemicals and how that can be improved from a sort of processing way. Well, lithium-ion batteries were already invented decades back, but they are now really entering into maturity both on the technical side and especially on the commercial side to really become a major industry. And from studies done, it's clear that this is going to grow rapidly. Within the next 10 years, we're going to reach half or even more half of the paper and pulp industry is in revenue currently. Also, as mentioned several times during this webinar, the amount of electrical vehicles will increase enormously, up to 54 million euros. And all this has naturally raised quite a lot of concern about the sustainability, especially on the issue of sourcing the metals, mining the metals that is needed for this rapid growth, and also what is actually going to happen to these metals once the batteries really reach their end of life. Well, this is always an opportunity, and currently there's a lot of things going on in the world. A lot of small companies, a lot of large companies are working on developing recycling routes for batteries or recovery routes for the metals. And the market is expected to grow really to 15 billion euros within the next 10 years, which means that we're gonna have to sort of increase the capacity to process this battery by 25 times. Now, these are all actually predictions. Nobody really has the crystal ball, but everything really moves or seems to go in this direction. Now, sustainability, how can you actually achieve this? Well, the fact is that on the mobility, EU has set quite a lot of harsh targets on CO2 emissions, and the only way to really sort of reach this is to increase the electrical vehicle population. And looking into that, it's clear that there are a few things you can do about it. Naturally, produce more with less, so really efficient processes, but also to look into the real production of the electrical vehicles on all the parts within that chain. How can you reduce energy, use sort of green energy, and especially how can you minimize waste, or if waste still is being produced. How can you increase the recycling of this? And also not only to recycle it, but to reuse it within the production of electric vehicles. Now, EU came out with a new battery directive proposal end of last year with really ambitious targets. The recycling rate for consumer lithium-ion batteries has to increase up to 70%. On the industrial batteries, they are suggesting 100%, and even the metal recovery rates from these batteries will have to go above 90. Actually, the target is 95%. This really is challenging chemistry that we need to develop in order to do this. But legislation actually drives for this sustainability. We need to follow the carbon footprint in all stages, and also it is going to be a requirement to really use the recycled raw materials. The proposal is that by 30 there will need to be 12% cobalt, recycled cobalt, and 4% recycled nickel in the batteries, and by 35 this will increase to 20 and 12%. These are huge numbers, because if you start looking at what is happening with the gigafactory or the battery production in EU, this was already presented by Matti Hietanen and Thor. A little bit different numbers. It's all about predictions and who believes what and at what dates. But when we have looked at existing plants now, how much they will need, how much sort of waste they produce, etc., we have come down to the numbers that are shown on the left. This is three times less than Matti Hietanen was presenting on nickel in his slides, but the sort of the size numbers are still correct. And we have calculated down that from production scraps already, and all kinds of other waste that are produced within these sort of large factories, we could sort of recover about 4% of the nickel and cobalt. So already targeting the first sort of targets within the directives. But we have to remember that how many of these plants will be in the future, nobody really knows. The fact is that from just sort of recycling the batteries, the EV batteries, it's going to take years. Here's the study I found from our neighboring country, Sweden, where they have predicted that all the batteries that when put on the market before 2018, when will they actually end up as either a second life or in recycling? And you can see from this figure that this is going to be late. We are not going to see any huge amounts of EV batteries for recycling in 10 years. The fact, as we heard from both Turku and also other, that the battery's lifetime is longer than predicted. So by just sort of sourcing it from battery recycling, the amount we need to replace according to the EU directive is not going to be, at least in short term, enough. So within Fortum, we have moved our sort of looking into where can we find nickel and cobalt, manganese, why not lithium from other sources. I looked into industrial side streams, spent catalysts within the other areas. And yes, there are significant amounts of both nickel and other metals present in these side streams. Even if they might be low, there are sort of amounts that should be recovered and brought into the battery value chain. Having said that, I don't mean that the recovery of batteries or the recycling of batteries wouldn't be important. It will be very important in the future, and especially processing of the off-spec materials from pecan production, CAM production, and cell production. But on a short while, we should start looking into how do we do that. And this is where actually Fortum and Crystaltech is today. Currently, we operate a pilot plant in Harjavalta in the sort of 100 tons of scales, just to sort of learn the process. Recycling batteries, recycling industrial side streams is not an easy task, especially if you want to reach high yields. But we have already filed and approved EIA we are expecting to get the chemical permits, the environmental permits for the next generation plant by summer. And that plant is expected to have capacities up to 50,000 tons of materials. But Fortum is not only active in the hydrometallurgical side or recovering or production of these metals, already have experience naturally as an energy company to produce CO2-free energy. And we are also a really big user of batteries, storage batteries, in combination with the hydro plants we have. There are also activities around sort of consumer supporting in EV on electrification, and naturally with our expertise in hazardous waste services, we see that we have a key role in supporting all the value chain within the batteries from other hazardous waste as well. So just wrapping up is that we aim to be the top producer of sustainable battery chemicals, but not from primary resources, mainly from secondary resources. So we have three basic raw materials coming in. Naturally, the end-of-life batteries, where we process them mechanically in order to separate all the plastics, the foils, the electrolytes, etc., etc. And then production scrap, which is usually similar material to the batteries, but a lot easier to process mechanically. And then we are partnering up with sort of major producers of side streams in order to recover the metals. And our key is naturally the hydrometallurgical processing and the know-how in how to environmentally safely separate nickel, cobalt, manganese, and lithium into new products, new recycled sustainable products to the battery metal producers. And by doing this, we feel that we at least will reduce the sort of political supply risk from outside Europe. We aim to keep the batteries and the raw materials within the European borders and reuse and use them here. Thank you very much for your attention.
Thank you, Kenneth, so much for your presentation. There does not seem to be any questions at the moment, but I would like to say one comment to each of the presentations, and I will start backwards with you, Kenneth. It was really interesting what you told about using the side streams for example, making it happen that we can use the necessary recycled material amount in the future. I guess that because there is quite a lot metal refining in Finland, and we have long tradition there, so we are quite strong in there. Am I right or am I wrong? What do you think?
Yes, you are correct and right. We have a long tradition on it. I say the main reasons probably that we have had mines in the northern part of Europe, especially in Finland, and there's a strong expertise on this. And we have sort of, as Turo already mentioned, we have a cluster in Harjavalta where we work closely with Norilsk Nickel. We also work closely with other operators in Finland, and we learn from each other. We can solve problems together. I think this is a strength for Finland.
Okay, thank you. It was good to hear that from your part. Then I would like to comment both Tero and Mika that I think that what you presented us was circular economy of the use phase. It is not that much always discussed that how can you advance circular economy when you are using something. And I think your solutions are really important in this sense. Feel free to comment if you like to still.
Yeah, I could comment on accurate behalf, and yeah, certainly so. So obviously the data and the well, there is a saying that the data is new oil, but on the other hand, if you are not using the oil or you are not refining the data, there is no use. So it doesn't help to just be inactively somewhere without using. So smart usage of data is super important for the whole circular economy, because then you get inside the big data inside what is the condition of the batteries in the field and when they are coming end of life. So that is obviously also kind of giving a information how the material flows are going, meaning that you can predict the material flows also for the either for the second life or then for the recycling.
Thank you, Mika.
And Tero here, maybe to complement still Mika, I think we're actually doing quite a lot of cooperation with Mika, and I think we can really help on getting the data to the cloud, and then Accurate, for example, can really help on how to utilize that data. And of course, then there's a lot of other use cases also for the data, not just related to battery analysis, what Accurate is doing a lot. But anyway, I think both are needed. The solution to get the device connected, and then of course the real use of the data so that it brings value, like Mika said. It doesn't make any sense to collect data to the cloud if you don't do anything with it.
Yeah, absolutely. Thanks, Tero.
Yes, thank you on my half too. There was also a question now in the chat for Kenneth that Kenneth already also answered. The question was, can you share anything about your patented technology enabling high recovery rates? And the answer was not really yet, since patenting is still ongoing, but as soon as this is public, we can share. And of course, Kenneth, if you want to add something to your answer, please, you can do so.
No, not really, but I assume that Vesa and everybody else understands that this is an emerging market, so we don't want to too much detail share with others.
Okay, thank you. That's really understandable. I think we can move on with the program slightly ahead of time now. So would you like to go forth, Raimo? And thank you, Mika, Tero, and Kenneth for good presentations, and for this session 3. I forgot to thank you.
Okay, thank you also from my side. We are at the end of the session, and it's about time for a summary. First, I said that I hope that you have enjoyed the webinar, and most importantly, I hope you have learned something new. At least I feel that I still learn something new always when I hear other people talking. And one aspect which I would like to really emphasize is that the battery, it's not only about batteries, it's also about applications, how they use and how they're used in real life. And it's also about energy grids and circular economy. That's kind of my very short summary. So I move to the next slide, which will tell you the participant that the materials and recordings will be published, and we'll send the links to the participant of this event, and it might be also that it will be completely public. So I guess that's all from my side. I think I turn my floor to Johanna now, so Johanna can continue the final slides.
Okay, thank you, Raimo. So here are some news about our future events. You can go to next slide. Thank you. So we are planning an networking and knowledge sharing event that is about safety in the life cycle of batteries. If you are interested in this event, please contact me. There's my email address. Then on 17th of March, we have a webinar that's about 3D printing or additive manufacturing of metals and what role they have in e-mobility and electrification in the future, especially. And you can already register to the event, but the details of the program will be added later. And on April, we will have a webinar where we can hear current news on the batteries proposal from the Ministry of Environment. And we are hearing that what kind of feedback there has been in the European Commission from the EU members to the proposal. And on May, we will have a webinar about automation solutions in recycling of batteries. That will be the registrations that will open later. Do you want to say something on your side, Raimo, about the other themes?
Yeah, we have not set the date for example, the parts of the automation and robotics which is related to this electrification of almost everything. Then we are planning to have also webinars or sessions on regulation, standards, and safety, because those are very important because it's emerging field. They are not really fixed yet. So there's a need a lot of discussion between different partners or parties. What kind of things should enter there? Then today we didn't have a chance to have people talking about the maritime side of the electrification, but we do have a lot of competence here in Finland. So we are planning to have a specific event for maritime and electrification business. Most probably in the fall or end of summer. Then we're also planning to have innovation competition, but that's not yet settled how we handle that. So I guess I step now back, and Johanna, you can continue about the next newsletter and things like that.
Okay, thank you. So you can follow our future plans in this project and the future events by signing up to our newsletter. The link to subscribe to our newsletter will be in this presentation. Then you can follow our event calendars, both in Turku Business Region side and in Yrityssalo. So the links are in this presentation too.
And same here in Finnish, that so we'll distribute the material. But from our side, this is all today, and we really thank all of the speakers for your time and effort to present the comprehensive picture of what's happening in Finland, and more specifically in southwest Finland, Varsinais-Suomi, or Länsirannikko, I would also say differently. So thank you very much. So I don't know whether Johanna, you want to say more or.
Yes, I just want to inform and market that we will have our new site opening soon, eFlowHub.fi, where we will gather information about the project, about the companies and organizations in the Southwest Finland area, and of course all the event materials and stuff like that will be finally there. But please follow this address, and of course we will ask the Southwestern Finland parties also to join the site. So please expect to hear from us, and expect to hear our questions for you to join this our new site. But we will get to that later. Thank you.
And finally, before I close this, is that that if you want to contribute to the efforts which we are doing, because our role is mostly being catalyst to catalyze the kind of cooperation between different parties, and so please join or send your emails to us so we can couple you with others, and also ask information from you. For example, we kind of have a need for make a common vision for what kind of things you would like us to do. Thank you. So I think that concludes the event. So hopefully you enjoyed, and kiitoksia. Ei enempää, nothing more, nothing less.